All right, everybody, here goes a video on just shaded regions and finding the area of them. Obviously, a prerequisite to knowing how to do this is to be able to find the area of any given figure at any time. So we're going to assume that you know how to do that for this video. So here we go. This first one, as you can see, is a square with 4 circles inside. So the first thing you always want to do is find the area of the biggest figure. So the biggest one is a square that's 20 by 20. So we know that the area of the square is 400 inches squared. Now what we need to do is we need to find the area of one of the circles. And then we're going to just multiply that by 4. So to find one of the circles, what you need to do is first figure out what the radius is going to be. So if there are 2 radii in each direction for this top part of this square, that means each one of these is going to be 5. And we know if a circle has a radius of 5, we just square the radius and have our pi symbol. So this is going to be 25 pi inches squared per circle, which means we have a total of 100 pi inches squared in circles. So to write your final answer, all you have to do is take the area of the big area, or the big portion of it, which is 400, and subtract the area of what's missing. In this case, all 4 circles is 100 pi inches squared. That's it. You're done. We're going to leave our answers as an exact value instead of rounding them. And you're good to go. This next one can be done 2 different ways. We can see that we have a rectangle, which is 4 by 8, which is 48. And then we have a rhombus on the inside. Now we know to do the rhombus, it's 1/2 of the diagonal 1 times diagonal 2. So one of our diagonals is going to be the base, which is 8 of the rectangle. The other diagonal is the height of the rectangle, which we know is 6. But since it's a rhombus, it's 1/2 diagonal 1 times diagonal 2, so this is 24. So 48 for the big minus the little one of 24 means we're going to have an area of 24 meters squared for this guy. Now I said there were 2 ways to do it. The other thing you might notice is the fact that all of these are just a 3 by 4 triangle. So you could just find the area of one triangle, which would be 1/2 of 4 times 3. So we get 6. And then we have 4 of them, and 6 times 4 is still going to give us 24. Just wanted to show you that sometimes there are options. Last one is a regular hexagon inside of a circle. So to do this, you have to remember, first thing you might want to do is draw this portion of it, like we've talked about before for regular polygons. And we know that this would be a side length. This is our apothem, and this is our radius. So we know the side length. We know the side length is going to give us 6. So you have to first divide 360 by 2 times the number of sides to find this inside angle, which is going to give us 30. So this is a 30, 60, 90 triangle. So opposite of 30 we know is 3 because this 6 has been split to 3 and 3. So the apothem is going to be 3 root 3, and the radius is going to be 6 because that's opposite of the 90, which is our 2s. Now you have all the information you need. You have an apothem of 3 root 3 and a radius of 6. So the first thing you want to do is find the area of the bigger part of it, and that would be our circle. So the circle is radius squared pi, so 36 pi. And after that, what you want to do is you want to find the area of your hexagon. Now we know to find the area of the hexagon, it's 1/2 of the perimeter, which is 36, times your apothem, which is 3 root 3. And that means your hexagon is going to be 1/2 of 36 is 18 times 3. It's going to give you 54 square roots of 3. So your final answer is 36 pi minus 54 root 3 meters squared. Now this one might stump you for a second because you see that it looks like you have a smaller number in front, but you have to remember pi is 3.14 approximately. So this is 36 times 3. This is only 54 times 1 point something. So it is in fact going to work out just fine. You can always check with your calculator to make sure you have a positive answer. Whenever you're doing shaded regions, if you have something like this and you type it in the calculator and you get a negative, chances are you reverse them. But in this case, the circle is bigger than the hexagon, so we have circle minus hexagon. And that's it for this. That's how you pretty much do any shaded region. Just find the area of the bigger stuff first, and then subtract the area of the smaller stuff, and you'll be good to go. This is Longo, and I'm out. See you, bye.